Hey guys, what's up? You know what? I'm doing another topic from glucose and fructose section. In case you remember, in the previous lecture, I described you one of the very important reaction that confirm that glucose and fructose they both are reducing sugar. You already know that they are reducing sugar, but with the help of a chemical reaction, in the previous lecture, I let you prove that they both are reducing sugar, and that was tolerant test, right? What right now I'm doing, this is called Benedict test. So this is something new. You might be, listening it for the first time. What is this, Benedict test? I tell you about. It's a solution, with which glucose and fructose are treated. And this solution is called cuprous citrate solution. It's a blue color solution, which when you react with glucose and fructose, converts into a red brick PPT. So in order to get everything, we have to do the reaction here. So let's do the reaction and see what this is. So I'm taking, glucose here, and what you do know, glucose has first carbon in the form of aldehyde, and you can represent the remaining part here as R. So this is this, presentation of aldose. This is aldose. So this is definitely representing both aldehyde and both glucose and fructose. Okay, now what you have to do, you have to react this glucose with the cuprous citrate. I tell you what, citrate has a very complex structure. I shouldn't be taking it right now. You can Google it. So what I'm doing, I'm writing citrate in a very short form. So this is cuprous citrate, and it's a coordination compound that can be represented by this formula. Now what happened? Actually, this solution has a blue color. So this is a blue color solution, right? And this blue solution is a mild oxidizing agent. So once you start adding the cuprous citrate into aldose, what happened? This glucose or the aldose convert into carboxylate. It happens to be something like this. So this convert into carboxylate. Right? Along with that, you also obtain a red brick or brick red PPT, a brick red PPT, right? And that's of, copper oxide. So what is happening here is that the copper is having oxidation state of +2, but there it's coming in +1 form. So definitely copper is undergoing reduction. What that means? That this carbon is undergoing oxidation. So what is the purpose here? This mild oxidizing agent oxidizes the glucose and converts it into carboxylate, and therefore it simply proved that glucose is a reducing sugar, while this one is a oxidizing by nature. So this is reducing by nature and this is oxidizing by nature, and this information is enough to prove that glucose is also reducing. Now let's do the same reaction with fructose, but you might be having a question in your mind that a fructose doesn't have aldehyde. So how a mild oxidizing agent can convert ketone into carboxylate, right? In case you do not have this question coming up, let me repeat that. A ketone cannot be oxidized by mild oxidizing agent. So why, a fructose will result formation of the carboxylate? I give you the explanation right here. So I'm representing this fructose something like this. So the first carbon of fructose is in the form of CH2OH. The second is having ketone group, and I'm placing others in the form of R. So what you are doing, you are reacting again with cuprous citrate, and like you have seen up here, the formula is going to be, something like this. And what happened? This blue solution, changes to, okay, now get back to the question here. This mild oxidizing agent doesn't oxidize this ketone. It actually oxidizes the alcoholic carbon. So this first carbon undergo oxidation, and then it convert into aldose. So this is what happened here. This is, the first change happens to be. So what that means? Fructose first convert into aldose, and then in the secondary step of the reaction, again this reaction is taking place. Let me write the complete one. So you have again cuprous citrate here. Cuprous citrate, and Due to the reaction, this converts into a carboxylate. So this gives you the carboxylate. This gives you the carboxylate. And along with that, you also have this Cu2O, brick red PPT. Brick red PPT. And there is your carboxylate. Now let me repeat everything here. What I just did, that a glucose when react with cuprous citrate, the Benedict solution, it directly converts into carboxylate, because even a mild oxidizing agent can oxidize aldehyde into carboxylate, right? And therefore, the aldose is converting into carboxylate. But in the fructose, there is no aldehyde. So what happened? First, it converts into aldehyde, and after it converts into aldehyde, it gives the reaction remaining like the glucose. So the first is the fructose convert into glucose-like, and then the glucose oxidizes itself, get oxidized and convert into carboxylate, and this is what exactly the whole reaction is about. And both of these reactions prove that glucose and fructose, they both are reducing sugar, right? So this is the Benedict solution test, right? One more thing, Benedict solution, it's something you may not find in your NCERT book, but this is again something you should pay attention for your upcoming competitive exams. So through these two equations, glucose and fructose, they both have come to an end, and in the next section I will start the sucrose one, and then maltose and lactose would be coming up. I must wind this here. I'll say thanks for watching, take care and have a good day.